Rate, rate of change of velocity is called acceleration. Now, a man wearing a wingsuit glides through the air with a constant speed of 47 meters per second at an angle of 24 degrees to the horizontal. Means that if this is a horizontal thing, then he is going down by 24 degrees. Okay. So the path of the van is shown in the figure. The total mass of the van and the wingsuit is 85 kg. The man takes a time of 2.8 minutes to glide from point A to point B. With reference to the motion of the man, state and explain whether he is in equilibrium. What are the conditions for something to be in equilibrium? In the back of your head, you should recall conditions of equilibrium, which are number one, no net force. Number two, no net turning. So no net force means no acceleration. If there will be no net force, there will be no acceleration. Is any part on this? Is there any part on this diagram where the examiner says that object is accelerating, or is there any part or any part of the statement that confirms that object is not accelerating? Okay, so if you go to the part that I underlined, that it is traveling with a constant velocity, it means constant velocity. Neither the object's speed is changing nor its direction of motion is changing. So we can say, yes, he is in equilibrium falling with constant speed in straight line. So no acceleration and no net force. And neither the object is turning or there is any turning effect. Show that the difference in height h between the point A and B is 3200 meters. So we are looking for this thing. How long is A to B? Part A to B. How long is part A, B? This depends on how much time is there and what is the speed. So these two things together, they can tell you about how much distance is between A and B. And then using trigonometry, we can find out height h. Now see. Distance AB equals to 47 multiplied by 2.8 multiplied by 60. And height will be 47 into 2.8 into 60 into sine 24. 47 into 2.8 into 60 into sine 24. $3211.6, which is approximately okay. How many of you got this one right? The mass of the person is given as 85 kg. G is 9.8 newtons for each kg. And change of height, as we have calculated in the previous part, is 3,200 meters. Use this to find change in gravitational energy. Decrease in the magnitude of the force on the man due to air resistance. Loss of gravitational potential energy equals to work done against air resistance. So work done equals to force into distance. Distance travel is 47 into 2.8 into 60. Because you won't take the height, you will take the distance travel against the air. That will be the distance from A to B. And work done will be change of gravitational potential energy that you have calculated in the previous part, and you can use it to find force. Now, determine the density of the air. Yes?
For the third part, I got the answer. It's a really big number. What else?
बेटा आपकी आवाज क्लियर नहीं आ रही है. Can you speak up?
सर पिछले पार्ट का आंसर बताऊं क्या? मुझे कंफर्म नहीं है कि वो सही है नहीं.
बताएं.
266,000.
266,000.
5600 66 के बाद.
नहीं, आप मुझे एक एक डिजिट करके बता दें आराम से.
2665600.
5600.
Sir, I said 2665600.
अच्छा 2665670. मैं चेक कर लेता हूँ. लॉस ऑफ पोटेंशियल एनर्जी M 85 into 8126 2.7 मिलियन. ठीक है. (2.7 into 10 to the power 6 joules. Good. अच्छा, यही जो लॉस ऑफ potential energy and loss of gravitational potential energy, that is again work done against air resistance. You would say कि सर आपको कैसे पता चला? How do you know कि ये equal to air resistance? The answer is very simple. There is a loss of gravitational potential energy, we can see that, but there is no gain of kinetic energy. Object is falling with a constant speed. इसका मतलब है potential energy तो कम हो रही है, kinetic energy ज्यादा नहीं हो रही. So all the work done by the gravitational force, gravitational field is converted into work done against air resistance. तो इसका मतलब है कि जितनी भी पोटेंशियल एनर्जी लूज होगी ऑब्जेक्ट की, वो सारी की सारी वर्क डन अगेंस्ट एयर रेजिस्टेंस बन जाएगी. तो वर्क डन का फॉर्मूला होता है फोर्स इनटू डिस्टेंस. अब इसमें हम डिस्टेंस लेंगे ए से बी तक का जो डायरेक्ट डिस्टेंस है वो होगा 47 into 2.8 into 60, और उसके बाद फिर हम चेंज ऑफ वर्क डन जो है, जो वर्क डन है वो चेंज ऑफ ग्रेविटेशन पोटेंशियल एनर्जी के इक्वल. यानी 2.7 × 10⁶ जूल्स, और फिर इस सब को यूज करके फिर हम फोर्स फाइंड करेंगे कि कितनी फोर्स लग रही है उस पर। उससे अगले वाला पार्ट प्रेशर का है, अभी हम उसको भी छोड़ रहे हैं, हम आगे चल रहे हैं। स्टेट टू कंडीशंस ऑफ इक्विलिब्रियम। अच्छा, इसके बाद कौन सा क्वेश्चन किया हुआ है आप लोगों ने? अब फिर हम वही करें। Okay, define acceleration. This is a repeated question. Acceleration is rate of change of velocity. A man travels on a toboggan down a slope covered with the snow from point A to point B and then point C. The path is illustrated in the figure. Toboggan at rest. The slope AB makes an angle of 40 degrees to the horizontal and slope BC makes an angle of 20 degrees with the horizontal. Friction is not negligible. So it means that the force of friction is a significant force over here. So we cannot just simply say that we are ignoring a resistance. It means a resistance will be making a difference. The man and the Trojan have a combined mass of 95 kg. The man starts from rest and has a constant acceleration between A and B. The man takes 19 seconds to reach B. His speed is 36 meters per second at B. Calculate acceleration. Now, this is the data we have. U is 0, V is 36, A is a question mark, T is 19. Is this information enough to find acceleration?
Yes, sir.
Yes, sir.
A equals to V minus U over T. So 36 over 19.
1.89.
1.89?
Yes.
Good. Answer 1.9 and 1.89 both. Show that the distance moved from A to B 340 meters. U is 0, V is 36, T is 19, and we need distance. So what formula we can use? Actually, any formula of constant acceleration, any formula of constant acceleration that has S in it can be used to find distance over here. Because when we get four variables, if four variables are given and fifth one is missing, you can pick any formula and put the values in and calculate the answer.
सर आपकी आवाज थोड़ी कटी थी, आप दोबारा बोल सकते हैं क्या?
मैं ये कह रहा हूँ कि जब आपके पास चार वेरिएबल्स हो जाते हैं ना, देखें ए वी यू एस टी, ये 5 वेरिएबल हैं। अगर आप इसको इनमें 4 पता चल जाए और 5वां पे पता चलाना हो, तो आप कोई भी फॉर्मूला पिक करेंगे ना, तो उससे वो आप फाइंड कर सकते हैं। लेकिन देखें S equals to U plus half AT square. Can you use this one? Answer is yes.
Yes.
S equals to VT minus 1 over 2 AT square. 2AS equals to V square minus U square. S equals to 1 over 2 U into T. I would suggest, just to get the confidence of the formulas, You put values in all four of these formulas and calculate distance and see if you get the same answer or not. Are these formulas correct? Are these formulas capable of finding the same value in four different ways? Very quickly, put values into all four formulas and calculate answers. M v square minus u square. And in this case, u is 0. So, and m is 95, v is 36. I can easily find the change of kinetic energy. Change in potential energy. Change of potential energy will be mgh. M equals to 95, g equals to 9.8, and height or change of height will be equal to 340 sine 40. Because if something is like this, 340, this angle is 40 degree, and we need this height. This is height. So if we need this height, we can use this trigonometric ratio sine theta. Actually, we need the vertical component of the displacement. So use 340 sine 40. Put the values in. Try to calculate the change in kinetic energy. Use your answer to determine the average frictional force that acts on the work done against friction equals to loss of gravitational potential energy minus gain of kinetic energy. If there was no work done against frictional force, then loss of gravitational potential energy should be exactly equal to gain of kinetic energy. But the two answers that you'll get here and here, they won't match. The answer for 3.1 and 3.2, they will not match. Theoretically, they should be if there is no frictional force. But if there is a frictional force, loss of gravitational potential energy will be more and gain of kinetic energy will be less. It means the gravitational potential energy that is lost, some of that is converted to kinetic energy and some is been converted to work done against friction. So we use this formula to find out work done against friction first, and then work done against friction equals to frictional force multiplied by distance moved. And we know that distance is 340. Work done we can calculate from the previous calculation, and this is how we can find out frictional force acting or average frictional force acting. The parachute opens on the toboggan. As it passes point B, there is a constant deceleration of 3 meters per second square from B to C. Calculate frictional force that produces the deceleration between B and C. Force equals to mass times acceleration. So all you have to do is find, this will give you the net force. And this is the toboggan. So frictional force is acting upwards. Mg sine theta is acting downward. Theta in this case, and you should add ff minus mg sine theta equals ma. So you put values into this equation and you can find out mm. So first, calculate change of kinetic energy. Now change in potential energy. (95 into 9.8 into 340 sine 40. 203,000. So this will be the loss of gravitational potential energy. So you can clearly see the loss of gravitational potential energy is more and gain of kinetic energy is less. Now, how can we find out how much work is done against frictional force? Loss of gravitational potential energy is actually the reason behind increase in kinetic energy as well as work done against frictional force. So we should do this. 203,000 minus 61600. What do we get?
141400.
I couldn't understand that. Can you? So this is work done against frictional force. So friction force will be divided by distance moved, that is 340. So 416, 420 newtons. 420 newtons. Now, this object has been placed on a surface like this. So because when it goes to part BC, remember the frictional force should change. He says that it is producing a deceleration of 3. Like acceleration along FF is 3. So FF will be 3 into 95 plus 95 into 9.8 into sine 20. Three into 95 plus 600 Newton.